All right, guys, so let's take a look at our first proof of the year. So whenever you're taking a look at a proof, there will always be some sort of given information, whether it's in the form of just some statements, such as here we have ST equals RN, IT equals RU, or it's in the form of a diagram. Okay, a lot of times both will be given because it will be some statements in regard to a diagram. Also, sometimes on the diagram you might notice there will be some sort of line like that, a line through IT, a line through RU. Okay, what that little line or that little dash means is that those two segments are congruent. So this tells us that that segment IT is congruent to segment RU. Well, we know that because looking down here, we have IT is equal to RU. Okay, so in this case, we're given two pieces of information. We're given that ST equals RN and IT equals RU. Our goal is to prove that SI is equal to UN. So whenever we set up a proof, we start by creating this T-chart. All right, on the left side, we have our statements. So statements, these are just facts that we write down that we know have to be true. And we know they're true based on our right column. Our right column is called our reasons. Okay, well, what kind of stuff goes into our reasons? Our reasons are our properties. Okay, so if you remember that worksheet where we talked about properties of equality, properties of congruence, such as the addition property of equality, the subtraction, multiplication, substitution, distribution. Okay, so properties, postulates, theorems, and definitions. Okay, those can be our reasons for any of our statements. So as we go through and we're trying to do this proof, the first reason and the first statement that we're always going to give is our given information. Okay, so step one, let's just write our given information. ST is equal to RN and IT is equal to RU. And just bear with me if my handwriting's a little poor. Using the iPad can sometimes be a little bit tricky. Okay? And my reason for that, like I just said, well, that's the given information. Okay, so step one, we always want to get the given down there. All right, so now that we have that, let's take a look. Okay, let's take a look at our information that's given, and then let's just take a look at the diagram. So ST is equal to RN. Well, that tells us this here is equal to this here. Okay. And then I have IT is equal to RU. So IT is equal to RU. And then what's our goal? Well, our goal is to prove that SI is equal to UN. And looking here, well, we can kind of see what's happening, right? We can see that SI plus IT is equal to ST, right? And what's the postulate that says that has to be true? Well, we're adding segments together, so that's segment addition. So we're always looking for how can we relate given information with what we're trying to prove. Well, SI and IT make up ST, so let's start with that, right? That's all pieces of information that we're either given or we're trying to get to eventually. So let's write that down. SI plus IT is equal to ST. And we know that's true because of segment addition. Okay, segment addition postulate, but if you just write segment addition, that's fine. Okay, and we could do segment addition again, right? We did it for the top segment, right? We did it for this one. Let's do it for this one now. Okay, so if I'm setting this one up, hopefully you can take a look, and this one's pretty easy to set up on your own. If not, I know this is our first time going through a proof. RU, so this short segment plus this segment that's a little bit longer, plus UN is going to be equal to that entire segment, which is RN. Okay, and that makes sense, right? RU and UN combine to make that RN. And we don't need to write segment addition again. because we're just combining this into one step, right? We're doing segment addition just on two different segments. All right, so now that we have that, this is where things can get a little bit tricky as we move on to step 3. So, looking here, well, I have ST is equal to RN up here, right? ST is equal to RN, and I'm going to highlight those in colors. Why am I going to do that? Well, look at this statement down here. Statement 2, SI plus IT equals ST. Well, here appears ST, and I know ST is equal to this SI plus IT. So, what could I do? Well, I can take SI plus IT, and I could substitute it in right there. I could substitute it in for ST. Same thing with RU, or RN. Right, I have RN is equal to this whole statement right here, RU plus UN. Well, I could take that, whoop, plug it in right there. So this new statement I can take, substitute in that green part, SI plus IT is equal to RU plus UN. And what am I doing again, right? What's my reason for that? That's just the substitution property, right? I'm substituting in, I'm plugging in, substituting in. They really mean the same thing. All right, step 4. So my end goal, the last thing that I want to be writing down is this SI is equal to UN. Well, if I look here, and I'll highlight this in a different color, I have SI and I have UN, right? Well, I just have these two other terms that are kind of in there, right? IT and RU. Well, where have I seen IT and RU before? Right, let's go back through. Let's look at what we've written down. Oh, well, look at this nice piece of information that I haven't really used yet, right? IT is equal to RU. So what can I do? I can subtract that from each side, right? Subtract IT and RU from each side because they're equal to each other. If they weren't equal to each other, I wouldn't be able to do that. But we know they're equal to each other. So that's like saying, well, if you subtract 4 from the left side, you have to subtract 4 from the right side. So down here, well, if you subtract IT from the left side, you have to subtract something equal to IT from the right side. Well, guess what? RU is equal to IT, so you're allowed to do that. So SI is equal to UN. And what did I do there? That is subtraction, and it's the subtraction property of equality, and I'm just going to draw an equal sign for that. Okay, so just recapping this, start off, give the given, okay, write the given down, then take a look at the diagram, take a look at your given information. How can you relate them? Okay, in this case, we were able to relate it using segment addition. Then look at the statements that you have now created. Look at the previous statements you have from the given. Again, how can they kind of relate, and how can you start moving in the right direction? How can you start moving towards this here, this SI is equal to UN, right? We want to be able to write statements that contain SI and UN. Okay, it's sort of like working your way through a puzzle. You're just taking step after step, right? Trying to get to that end goal of SI is equal to UN, to get to that prove statement. Okay, so just as you go through the proof, keep looking back. What do I know? How can I relate it? And how is that going to help me get to the next step, which eventually will get me to my end goal and my proof statement? All right, the next proof we're going to take a look at has to do with angles. All right, so in this next example, we're taking a look at a proof with angles now. And I actually forgot to put in that this here is angle 4 and this here is angle 3. All right, so we are given that measure angle 1 is equal to measure angle 3. So here's my 1 right here. Here's my 3 down here, right? Angle HED. And measure angle 2 is equal to measure angle 4. Okay? And now I want to prove that measure angle ABC is equal to the measure of angle DEF. So just thinking about it, does it make sense? Yeah, it makes sense that these two are going to be equal to each other. Looking at the diagrams, a way that it'll commonly be marked in a way when you can tell that two angles are congruent, what they'll do is for measure angle 1, they'll draw one line, and for measure angle 3, they'll draw one line. Just like that, one little curve. That means that those two are congruent. If they want to say that two other angle measures are congruent, this time they'll draw two lines. Okay, it looks sort of like a little rainbow. So angle 4 is congruent to angle 2. Okay, and again, if you wanted another one, well, then you would draw 3 lines. Another set, you would draw 4 lines. Okay, but these red lines are just kind of showing you angle 3 is congruent to angle 1, angle 2 is congruent to angle 4. That's what those mean. All right, so let's go ahead and set up the proof. All right, draw my two columns, statements, ignore my bad handwriting here, and reasons. All right, so what's my first step? First step, always just put down our given info. All right, and I didn't give myself a whole lot of room. I'm going to try and do my best. Measure angle 1 equals measure angle 3, and measure angle 2 equals measure angle 4. All right, and what's my reason for that? Always my first reason. That's just the given info. All right, so given. All right, step 2. So our end goal, always keep that end goal in mind, right guys? The end goal is to get measure of angle ABC, measure of angle DEF. We want those two to be equal to each other. Well, looking at these two, ABC, well, what can I say about ABC? I know it's measure of angle 1 plus measure of angle 2. And how do I know that? Right, by angle addition. Same thing down here, measure angle DEF. Well, that's measure angle 3 plus measure angle 4. Again, just use the diagrams. Use what do we know? What am I looking at? How can I relate this given info to the info down here? Okay, in this case, measure angle 1 plus measure angle 2 equals measure angle ABC. So let's get that down there. Measure angle 1 plus measure angle 2 equals, and I'm going to have to write this on the next line, guys. Try to give yourself a little bit more room than this. Equals measure angle ABC. Okay, and I said that's angle addition. Angle addition. And I can also say measure angle 3 plus measure angle 4 is equal to measure angle DEF. So I actually don't have to write this as a step 3 because I'm still doing angle addition. I can combine it into step 2. So measure angle 3 plus measure angle 4 equals measure angle DEF. All right, so that's angle addition. So I want to be able to get this statement. I want to be able to say that measure angle 1 plus measure angle 2 equals, right? If I can say this, measure angle 1 plus measure angle 2 equals this, measure angle 3 plus measure angle 4, well, then I can just substitute in measure angle ABC, measure angle DEF, say those two are equal to each other, boom, I'm done. So looking back at this given information here, well, what can I do? Well, I can add the two together, right? And this is just using the addition property. Measure angle 1 plus measure angle 2 has to be equal to measure angle 3 plus measure angle 4. Okay, because, right, if you have A equals B and C equals D, A plus C has to equal B plus D. Okay, that's the addition property of equality. All right, so step 3, well, I can say those are equal to each other. Measure angle 1 plus measure angle 2 is equal to measure angle 3 plus measure angle 4. And what's my reason for that? Well, I'm adding these two together, right? I'm adding measure angle 1 and measure angle 2 And when I add those together, it has to be equal to measure angle 3 plus measure angle 4. Okay, because they are equal to one another. So this is the addition property. Addition prop of equals. Okay, you have two sets of things that are equal to each other, just add them together. And then step 4, and we were talking about this earlier, right? Going back up here, well, measure angle 1 plus measure angle 2. Oh, I see that right down here. So I could take this measure angle ABC and just plug it right in right there, right? Plug it in right over that. Same thing with this, right? Measure angle DEF. I can take that. Well, it's equal to measure angle 3 plus 4. I'm going to take it in, plug it right here for that. So my final step is measure angle ABC equals measure angle DEF. And right, I was plugging in here. I was plugging in or substituting. So that's substitution. All right, and an important thing to note here, guys, is just as I'm trying to organize my proof, make sure that your 1s line up here, your 2s line up, okay? Right, see how I left this nice gap in here so that my 3s still line up? Don't put number 3 up here and put the reason up here while your statement is down here, okay? Line them up. Keep it nice and neat. It's easier for you to see. It's easier for me to see. It's easier for me to grade and give you guys more credit. Okay, so as we work through these, just try to think, how can I relate the information that's given to the point that I'm trying to get to using the diagram, okay? Using addition, using angle addition, using subtraction, using substitution. Okay, so we're going to have to use all these different properties, postulates, theorems, so that we can get from the given all the way down to this statement that we're trying to prove. And that brings me to my last point, guys, is, well, what do we notice about our last statement? Every time our last statement is the exact same as what we're trying to prove. And that makes sense, right? In order to prove that something's true, in order to get to the final, or to complete the puzzle, right? You need to put in that last piece. So that's exactly what we're doing here, is we're finishing it off by stating this is true and this is the reason. This is why we know this has to be true. All right, so hopefully these help you as you're going on and doing your homeworks with proofs.